Hello and welcome back. So in the last video we were looking at intervals, and we'll use intervals to help express solutions to linear inequalities. So a linear equation, like we saw before, is just an equation that has a polynomial on the left hand side and is equal to 0. This polynomial is just going to be ax plus b. Again, we have a linear term, which is going to be the ax, and a constant term, which is the b. And a linear inequality is going to be the same thing, except we're going to replace the equal sign with an inequality. For instance, ax plus b is less than 0. Ax plus b is greater than 0. And it doesn't have to be strictly less than or strictly greater than. We could have is less than or equal to, or is greater than or equal to. So any one of these is going to be a linear inequality. And essentially we just have this really simple linear polynomial on that side. So these aren't going to be especially difficult, but there are a couple things to keep in mind. So solving inequalities works nearly the same as equations when there's an equal sign, outside of one difference. So let's look at the things that are the same. So for instance, addition and subtraction work essentially the same. If a is less than b, then I can add a number to both sides of an inequality and nothing changes. If a is less than b, then I can subtract a number from both sides and nothing changes. Addition and subtraction are very simple here. So for instance, if I have x minus 3 is less than 7, if I want to figure out how to describe x here, I would want to maybe add 3 to both sides to get rid of x, the minus 3 here. So if I take x minus 3 plus 3, and then I take 7 plus 3, these will cancel out, and I'll have x is less than 10. So again, in the interval notation, if I want to say every number less than 10, I'll take 10, and I'm going to go down less than that. And again, I'm not including 10, so it will be a parenthesis here. Again, in picture form, we've got 10 here, and this will be everything to the left of 10. Okay. Over here, I have 2x is greater than or equal to x, so maybe I can cancel this out by taking 2x, and I can subtract an x from both sides. And when I subtract the x from this side, I'll just get 0, and if I take 2x and I subtract x, this will just be x is greater than or equal to 0. Again, if I'm looking at every number that's greater than or equal to 0, it'll be 0 on up, so everything above 0, including 0, because it could be equal to it. So I'll have a square brackets there. And again, in picture form, if we have 0, this will be everything greater than 0. Multiplication, division work very similarly too for positive numbers. For negative numbers, we'll have to do something a little bit different, but we'll cross that bridge when we come to it. So for the moment, we've got a is less than b. Then I can multiply both sides by a positive number. And if a is less than b, I can also divide both sides by a positive number. So for instance here, if I have 1/2 x is less than 3, I can multiply both sides by 2. And by multiplying by 2, I can cancel out the 2 and the 1/2 to just get x will be greater than 6. And again, this is going to be every number bigger than 6, so 6 on up. Not including 6, so I have the parenthesis there. Here, I have 6x is less than or equal to 72, so I'm just going to divide both sides by 6 to get x is less than or equal to 12. And then again, this is going to be everything smaller than 12, so 12 on down. And again, this is including 12 because it could be equal to 12. So the last thing that we have to worry about is multiplying or dividing by a negative number. And this is the one thing that we have to be careful of. If A is less than B and C is negative, then A times C is greater than B times C. So notice that the equality went from less than to greater than. It flipped. And if A is less than B and C is negative, if you divide by a negative sign, oh, that's a mistake, the inequality will also flip. It goes from A is less than B to A over C is greater than B over C. So the inequality changes when you're multiplying or dividing by a negative sign. This is very, very important to remember. So as a very quick example, if you take negative 2 is less than 3, we know that this is a true statement. Negative 2 is certainly less than negative 3. If I multiply both sides by negative 1, so if I take negative 1 times negative 2 and then negative 1 times 3, I'm going to leave this blank for a moment. And when I simplify, I'm going to, on the left-hand side, I'm going to get 2. On the right-hand side, I'm going to get negative 3. And again, when we look at this, 2 is a positive number, 3 is negative, so 2 is going to be greater than 3. So once we multiply by that negative sign, by that negative 1, we had to switch. So it switches, going from there to there. So this is more obvious because these are just numbers, and we're more familiar with negative 2 and 3. When things start getting to having some x's in there, maybe it's less obvious. So we just have to know whenever you multiply or divide by a negative number, you must flip the inequality. So here, I might divide both sides by negative 2 to get rid of this sign. And when I do, I've got to flip the inequality. 0 divided by negative 2 is going to be 0. Negative 2x divided by negative 2 is going to be x. So again, this will be every number less than 0. So 0 down. Over here, I might multiply both sides by negative 3. So that the negative 3 will cancel out with the negative 1/3. So when we do that, we're going to flip this sign around, flip the inequality, so that instead of less than, it's going to be greater than, and negative 3 times 4 will be negative 12. So again, this is everything greater than negative 12. It's going to be negative 12 on up. So let's work through some examples where we have to do multiple steps. So here we've got 2 minus 3x is less than or equal to 5. Maybe I see, okay, I've got the x there, I want to get it by itself. So I'm going to subtract 2 from both sides to get rid of that. So we'll have negative 3x is less than or equal to 5 minus 2 is 3. And now I've got a negative 3 on both sides, or sorry, a negative 3 there, so we'll divide by negative 3. And remember, negative sign, I have to flip the inequality. This is going to be x is greater than or equal to 1. This isn't the only way to solve this question. Maybe I don't like multiplying or dividing by a negative number, and I just want to avoid that. In this case, I can. I have a negative 3 times the x, and I'm afraid to divide by that negative 3. So what I can do is I can add 3x to both sides. Why would I do this? Well, 2 minus 3x plus 3x, these guys cancel, and I'm just left with 2, is less than or equal to 5 plus 3x. Now I don't have to divide by that negative 3 anymore, because it's a positive 3. So I will subtract 5 from both sides. 2 minus 5 is negative 3, is less than or equal to the 5 and negative 5 will cancel out to give me just 3x. And I can divide both sides by 3 to get negative 1 is less than or equal to x. And when we look at this, this is x has to be greater than or equal to negative 1, or x has to be greater than or equal to negative 1. We got the same answer in both ways. The entire equality or inequality is just flipped over. The x is on the left, and it's bigger than this. Here, the x is on the right, and it's bigger than this. In set notation and interval notation, this is going to be all of the x's bigger than -1. So everything from -1 on up, and we're going to include -1 because it's or equal to. Cool. So there is more than one way to do these questions. So here maybe I want to avoid the negative signs again. So what I will do is I will subtract a 3x from both sides to get, on this side I'll just have 1, it will be greater than 7x minus 3x is going to be 4x minus 15. Notice that if I subtracted a 7x from both sides, 3 minus 7 is going to be -4. So that's why I did the 3 instead of the 7. But it doesn't matter, both ways work. Here I'll add 15 to both sides. These guys will cancel, and I'll be left with 16 is greater than 4x. Again, I want to cancel out that 4, so I'll divide by 4, and I'll have 4 is greater than x. Or, another way of saying it, x is less than 4. Again, in the interval notation, this is going to be every number x that's less than 4. So 4 and below. Notice that we're not going to include 4, so it'll be a parentheses there. Fractions we handle in exactly the same way that we did before. So the least common denominator of all my fractions here, of 2, 3, and 6, the factors of 2 are just 2, factors of 3 are just 3, and factors of 6 are 2 and 3. So the smallest number that has a 2 is a factor of 3's, and the 3 is a factor is just 6 itself. So essentially what I'm going to do is I'm going to multiply everything by 6. So everything on the left-hand side and everything on the right-hand side. On this side, the 6 and the 2 will cancel to just give me 3 times x minus 4. On this side, if I distribute, the 6 and the 3 will cancel to give me 2 times x minus 2. And then the 6 over here, the 6 and that 6 will cancel to just give me 5. And now I can start to simplify a lot more. 3 times x is x, 3 times -4 is -12, 2 times x is 2x, 2 times -2 is going to be -4, plus 5. I will take this right-hand side and simplify it a little bit more. -4 and 5 together will be 1. I will subtract a 2x from both sides. When I do this, the 2x and the -2x will cancel. That'll just leave me 1 on that side. And I will have, 3x minus 2x is just going to be 1x, or just x by itself. I'll erase this for now. And I will add 12 to both sides to get x is going to be greater than or equal to 13. So inequalities are fairly straightforward, but we'll see in the next video that there are some unusual cases as well that we'll just have to be careful with.